Hi guys, in this video we're going to take a look at section 20.11 on alcohols. First thing you have to be able to do is identify alcohols. You're going to be grappling with about 7 different kinds of functional groups and their associated molecules in this chapter. And so alcohols are pretty straightforward. If there's an oxygen, oxygen's always red in these ball and stick diagrams, and a hydrogen attached to each other like this, that's always going to indicate an alcohol. If you recall chapter 4, when you learned to name molecules, that oxygen and hydrogen combination is called hydroxide. So this right here is hydroxide, and it actually had a negative charge on it. The idea here is that we started with a molecule of methane, we pulled off a hydrogen atom and attached the hydroxide ion in its place. Or in this case, we started with a molecule of ethane, removed one of the hydrogens, and inserted a hydroxide in place of the hydrogen. And that's the case in all of these images. In fact, that's the case with any alcohol at all. We'll see later in this section, you can pull off 2 or 3 or even more hydrogens and replace them with hydroxides, and they're still alcohols. So the first thing you need to be able to do is identify molecules as alcohols. You also have to be able to name some simple alcohols, and the naming is pretty straightforward. As I just said, the way that this molecule got built was we started with methane, removed a hydrogen, and put a hydroxide ion, OH, in its place. Since this used to be methane, the root of the name is methane, but you'll notice we've taken the E off and replaced it with OL. So after this is turned into an alcohol by adding OH, or hydroxide, it changes from methane to methanol. The same thing here, we pulled a hydrogen off of this ethane molecule and added the OH, the hydroxide. That means ethane changes to ethanol. Now this used to be a propane molecule. We pulled off a hydrogen, added the hydroxide to turn the molecule into an alcohol, but there's the following issue. Propane was large enough that we could have put the hydroxide on the first carbon, but we didn't. We put it on the second carbon. That means we have to say, starting with propanol, we have to say if it's 1 propanol, in which case the hydrogen would be sticking off the end here. And in fact, that would look like this, yeah, with the hydroxide sticking off the end. Or whether the molecule is 2 propanol with the hydroxide coming off the second carbon. In this case, it's in the middle, so we call it 2 propanol. You say, Cato, could we have numbered 1, 2, 3? Could we have put this hydroxide over here on the third carbon? Or if you want to count 1, 2, 3, could we have put the hydroxide on the third carbon on this side? And the answer is no, because you always want to name putting the functional group on the smallest numbered carbon. And so let's say that we took this, just like this, and we could number it 1, 2, 3 and call it 3-propanol, but that would be wrong. Instead, we have to number it 1, 2, 3 and call it 1-propanol. The reason for that, again, is that the functional group, in this case hydroxide, always has to go on the smallest numbered carbon. So here are a couple more examples. This is 1-propanol, as we just talked about. This is butanol. 1, 2, 3, 4 carbons is a butane molecule. We removed the hydrogen, put on the alcohol functional group. Now you say, could we name it 1, 2, 3? Could this be 3-butanol? And the answer is no, for the same reason as before. You've always got to have the smallest possible number here. And so we have to number from left to right, 1, 2, 3, 4, and this is 2-butanol. So basically you find out what the name of the molecule would be if it didn't have the alcohol functional group on it. You name it, and after that you just stick an OL on the end of it. And now you've named an alcohol. The next thing you've got to do is figure out if these are primary, secondary, or tertiary alcohols. And yeah, absolutely, baby. And the reason for doing that is whether or not these alcohols are primary, secondary, or tertiary will determine some of their properties. And you can kind of see that by looking at these pictures. The primary alcohol is longer. The tertiary alcohol is much rounder. And as you learned back in section 20.2 or 3 or so about the properties of alkanes, longer alkanes tend to boil at higher temperatures, whereas the shorter alkanes tended to boil at lower temperatures. That's one example of how shape affects physical and chemical properties. So this is easy enough to do. You just have to follow a series of steps. The first step is identify the functional group. So here's our hydroxide. The functional group is attached to a carbon. And now you look at that carbon and you say, how many other carbons is it attached to? In this case, it's attached to only one other carbon. Since it's attached to one carbon, we call that primary. Here's another example. Identify the functional group. The functional group has to be attached to a carbon. How many carbons or how many other carbons is this carbon atom attached to? One on the left, one on the right. Since there are two other carbons, this is secondary. And then in the final example, find the functional group. That functional group has to be attached to a carbon. How many other carbon atoms is this one connected to? 1, 2, 3. This is tertiary. So you should be able to identify those. The process is always find the functional group, find the atom the functional group is attached to, and then ask yourself how many other carbon atoms are connected to that. So here are some interesting alcohols. We looked at some basic things like ethanol, methanol. We'll go into a little bit more detail on those in the next section. But there are many, many different kinds of alcohols. And these are just 3 of them that are kind of interesting. Here's glycerol. Glycerol has a variety of different industrial applications, quite often to do with food. But not always. There's some other things too. But you'll notice that it's got 3 functional groups on it. That's fine. There isn't a rule about how many functional groups a molecule can have. One of the things that these functional groups do is they make the molecule soluble or dissolvable in water. So if you take this one, this is erythritol. It's called a sugar alcohol. Erythritol would be used in something like ice cream that you want to have sweetened. But erythritol is interesting because our bodies don't digest it. And so it's effectively a 0-calorie sweetener. In order to absorb the calories of a food, you've got to be able to digest the food. And our bodies simply can't digest this molecule. So your tongue tastes the sweetness of the erythritol, but your gut doesn't absorb it, digest it, process it in any way, and so it passes right through you. It's often referred to as a 0-calorie sweetener. But if you took off all these functional groups and just put hydrogens in their place, this would be a molecule of butane. Now you've probably seen butane. It's the liquid in butane lighters. Butane and water won't mix. The butane will be lighter than water and float on top of it. But by taking off hydrogens and adding these functional groups, the hydroxides allow this molecule to now dissolve in water. Same for glycerol. Glycerol will dissolve in water. And so erythritol can be mixed with any sort of a liquid solution because it will dissolve very nicely in water. And here's menthol. Menthol's all over the place. I think of cigarettes, for example, when I hear the word menthol, but it's used in many other things, including some kinds of medicine, I believe. But it has this one functional group right there. The rest of the molecule does get a little bit complicated, doesn't it? But it's got that one OH, and that makes it an alcohol. The other way you'll always know if you've got an alcohol is that the name will end in OL. So, in this section, you should be able to identify alcohols. You should be able to name some simple alcohols. You should be able to classify alcohols as primary, secondary, or tertiary, and you should know some of these other kinds of alcohols.